Dad.
Ya.
Tak dengar.
Ya.
Dapat tak email?
Email apa?
Email sebab baru email Dr. Zahar tu. Kan dia tanya Zoom limit pada berapa orang? Dia kata 100 orang. Hope this is enough, dia kata. Dapat kan?
Digunakan 300 orang kan?
Ya yang register dah berapa orang
Ramai ke?
Ramai, dah 1 lebih. 118.
Tujuh. Lepas tu ada orang masuk tak dalam tu? Zoom? Dalam
Google Meet ni pun on juga ni.
tu tadi masuk tadi.
Tadi masuk?
Tadi masuk tadi.
Dah on ni tapi tak ada orang admit Tadi je masuk, ada nampak tak yang slide tu?
Ada.
Okay.
Dr. Zah kata dia nak masuk ni kan? 245
kan? Dia kata dia nak start awal.
Dan dia nak try run dulu lah. Oh, ini boleh masuk 300 lah.
300.
Ini siapa punya ni?
Inspem punya.
Lepas tu nama Maisarah kan siapa pula?
Inspem actually dia ada beli juga. Apa tu?
Pertama sekali, terima kasih lagi saya ucapkan kepada Dr. Dzaharudin Mansor kerana melapangkan masa untuk sudi untuk berkongsi bersama kami. Dan Alhamdulillah ini adalah seminar mingguan Inspem yang ke-40 pada tahun ini. InsyaAllah hari ini kita ada lagi 2 sesi, itu hari ini dan 2 minggu lagi. Dan Alhamdulillah hari ini kita berasa bersyukur kerana kita dapat mendengar satu pembentangan daripada orang besar daripada Microsoft Malaysia. Dan hari ini juga saya sebelum saya serahkan kepada Dr. Zahar, saya menjemput Dr. Muhammad Rizal untuk mempengerusikan sesi ini. Yang selamat itu silakan.
Terima kasih Dr. Rizal. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon to everybody. Kepada Dr. Zahar, terima kasih.
Khabar, lama tak jumpa.
Lama tak jumpa. Jumpa cara macam ni je lah kita kan.
Yalah.
So, once again, macam mana tu? Ada ni kejap.
Mesti bilang ni remove Zoom.
1, 2, 3. Okay, it's okay lah. Okay. Right. So once again, thank you Dr. Zahar for your valuable time to share with us your experience. So I would take a few minutes to share with the audience a little bit of biodata. Maybe I can share my screen for a while. Is it possible? You cannot start sharing while other is sharing. Okay, all right. So okay, now it's okay. Right. Right, so I will read from this biodata. So this is Dr. Dzaharudin Mansor. So if you meet him somewhere in Kuala Lumpur, then just say hi. All right. He's the National Technology Officer for Microsoft Malaysia. He drives engagement with national technology stakeholders, which include academics, policymakers and advisors, and interest groups with the intention to build trust while contributing to national development. He joined Microsoft in 2005 and has more than 34 years of professional experience in ICT and telecommunications. He had his early career in Australia before moving to Celcom and even in Singapore. And currently he's in Microsoft, as we all know. Presently, he holds several associate positions, including adjunct professor at IIUM, which is UIA, counselor at PCOM, and academic advisor several public-private universities. His education background is that he has a degree in computer systems engineering from Monash, Australia in '85. I was in standard 3 then. He was awarded the Australian University Graduate Scholarship to complete his PhD in computer science in 88. In 85, he was awarded the Digital Award for Computer Engineering, University Tasmania Award for achieving top 10 position in HSC. He's passionate about technology that we all know. He works closely with academia and has research publications as well as professional certifications in various fields such as software engineering, computer architecture, cybersecurity, and so on. He aspires to contribute towards the nation's digital economy initiative. With that, I would like to give the floor to Dr. Zahar for his sharing session this afternoon. Dr. Zahar, you are muted.
Can you hear me now?
Okay, it's okay now.
And is the presentation on the screen?
Yes.
Good. Okay. Bismillahirrahmanirrahim. Thank you very much, Dr. Rizal. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone. First of all, thank you very much to UPM for inviting me to this session this afternoon. It's always a pleasure to be able to, sometimes interact with the academia. It's always, nice to be amongst the academia, because my first job was actually a lecturer in Australia, before you were born, Dr. Rizal. So what I like to start with is, if you look around us, we see that data and artificial intelligence really accelerating the pace of this fourth industrial revolution. And what COVID-19 has done is to force upon us this dramatic changes, the new normal way ahead of time, right? So this evening, we're happy to share my thoughts on why we all need to urgently accelerate our digital transformation, whether from an organizational perspective or even from a personal perspective, because we have to deal with a lot of unknowns in this post-COVID era. And I strongly believe that mathematics play a very central role in all this, right? So there'll be an area where I'll address that as part of my talk. But before that, perhaps it's probably a good idea for us to level set the understanding when I talk about the fourth industrial revolution. What does it mean? Because I think if I ask each of you individually what it means to you, I think I'll get different answers. Yeah. So I think if you reflect at yourself, when we talk about a revolution, it's a significant turning point in history, right? So if you talk about for yourself personally or socially, I think there has been changes. Yeah? Dr. Rizal, you think yourself 10 years ago or 15 years ago, right? And if you give a lecture and your students use a phone in a class, I'm sure you'll kick them out, right?
Yeah, sure.
But today, you'll see that if you give a lecture, these kids will be displaying with their handphone, right? And we assume that what they're doing is actually they're checking up on you, whether you're talking about the right thing. And I'm sure someone out there now is actually checking on my background and say whether he's a con man or what, right? So, in this new world, things have changed for us individually, right? As a social standpoint. But what about the economic standpoint? Has things really changed, right? So this is where, if you just Google out this report, right, United Nations Conference on Trade and Development Digital Economy Report, not long ago, it's published in end of 2019. One diagram actually caught my eye, right? And this is the market capitalization of digital companies around the world, including Asia, US, Europe, and so on, right? So it's a very interesting report. So I really encourage you to read this report. Now, a couple of observations, if you can see the name of the companies in there, and note that the size of the bubble is the size of the market capitalization of the company, right? And this kind of old data, if you look at Apple today, it's a $2 trillion company, right? It's bigger than Malaysia's GDP, by the way. So if you look at these companies out there, you'll find that not many of them actually existed in 1995, right? The few which existed is probably Microsoft, Apple, perhaps maybe SAP, maybe Samsung, yeah, and a few others, right? But most of the others really did not exist at the point of time. They came from nowhere, right? Becoming giants today in a very short period of time, right? Just to give an example, companies like Uber became a $40 billion company in just about 5 years, right? The second point I like to make, and this is where when people think about the fourth industrial revolution, they think about just manufacturing, right? And that's actually called Industry 4.0, which is different from the fourth industrial revolution. It's part of it, but it's not the whole thing. Because if you look at these companies, they come from various industries, right? You think about, okay, Microsoft and Apple and maybe SAP, they are technology companies, right? But think about Amazon and Tencent and Alibaba, they are actually retail or B2B companies. Think about Facebook and Alphabet, they are advertising companies, right? Netflix, they're a broadcasting company. You think about Uber and Grab, they're transportation companies, right? And you think about NTEF, probably a company that you've not heard before. They are the biggest fintech company in the world today, bigger than Maybank, by the way. Yeah? So it comes from across the board. I think the final thing I like to say is that competition in this new world, you don't know where it comes from. If I think about Microsoft about 10, 15 years ago, if I talk about our competitors, it will be the IBMs of the world and the Oracles of the world, Sun Microsystem, right? Those traditional IT companies. But today, the biggest competitor for Microsoft is a retail company and an advertising company, right? So you do not know where competition is coming from. And that's some of the challenges we see in this fourth industrial revolution. And if you don't believe you're in another industrial revolution, I think we should wake up. Now, if the first industrial revolution was powered by the steam technology, which changed from cottage industry to mechanized industries, transformed transportation from horse carriages to trains, for example, or sailing ships to steamships, what is really powering this fourth industrial revolution? And this is what analysts call digital platforms. Now, I so want to spend a few minutes explaining this because, again, if I ask you individually what digital means to you, probably I'll get different answers, right? So at least for the purpose of this session, let's have a common understanding. What is a digital platform? What's digital? Yes, it is about computing, but it is not just about computing. It's a bit more than that. It turns out it is a combination of technologies, of powerful technologies, which forms a platform. It's a mashup of technologies, right? So when we talk about digital platform, it's this combination of social and mobile, things that people use today, right? WhatsApp, Facebook, and so on and so forth. And all of you will have smartphones today. There's more, smartphones than Malaysians today, right? Or in Malaysia itself, for example, right? And all of this generates huge amounts of data that we need to process data in a different way, leveraging big data techniques. And with Internet of Things, that even generates huge amounts of data, even explosion of data, right? Now, and if you think about this, if you had to process things like terabytes of data per hour, you try to do it in your servers, you will not afford it, right? And how the small companies now can actually be successful is the fact that you have this hyperscale cloud computing infrastructure. That means we're not talking about 1,000 servers or 10,000 servers. We're talking about millions of servers, which are run by these few companies like, Microsoft, Amazon, maybe Google too, right? Where when you run computing at that scale, it reduces the cost of computing by an order of magnitude. And that is why the whole industry is moving to the cloud. When we talk about cloud, it's not virtualization. It's about the economics of computing, right? It really reduces the cost of computing and storage. And with a huge amounts of data, cheap processing, cheap storage, that is why we see artificial intelligence actually moving, really having progress in the last couple of years. Now, a couple of things I like to highlight before I leave this is it's about a mashup of technology. It's not individual. So that's why we cannot say it's just big data, or it's just IoT, or it's just, you know, cloud. It is this combination of technologies which forms a platform. And I'll show you how that works in the next slide. The second point I like to make is, I know a lot of you say that, well, technology is moving too fast, right? I have a slightly different point of view. I think if you look at the fundamentals of this technology, they've not changed much, right? Your mobile phone is just a computer, right? AI has existed in 1950s, but it is about the democratization of technologies, right? Think about it. The mobile phone in your pocket or in your handbag is probably 3 times more powerful than the computer which brought Apollo 11 to the moon. And it costs a fraction of the cost of that other computer. And aside from that, you don't need a rocket scientist to operate that computer, right? I mean, a 2-year-old probably can operate your mobile phone better than I can, for example, right? So this is about the democratization. Each of this has been democratized in this 4th industrial revolution. The final point I'd like to make is that all of this is internet connected. The moment you take internet out, it just breaks this disruptive effect that digital platform has. Again, I'll give you an example. Think about your smartphone. You switch off your Wi-Fi, you switch off your LTE, what does it become? It becomes a Nokia 3270, which I was using, you know, which I'm familiar with, for example, right? Now, just to show how this platform works together, think about Grab. I'm sure all of you have used Grab before, right? You know, the drivers, the passenger use a mobile phone, and really, if you think about it, your mobile phone is sending a lot of signals to Grab, right? And Grab's about to process these terabytes of data. And then when you ask for a car, it calculates for you the, you know, the closest car from the point where you are to the destination point, how much it costs, offers you the car. And then if you accept it, then it will then, you know, give us, you know, offers it to the closest car, and whoever accepts it then comes to you. They know where you are because you've got the GPS turned on and stuff like that, right? Now, if you look at what's happening here, you see the interplay of all these technologies as a platform, right? You use social because that's, you know, you have a lot of people contributing to the data. You use your mobile phones by the passenger as well as the drivers. And Internet of Things is just your accelerometer, your GPS on your phone, even cameras. Sometimes you take photos of where you are, right? And all of that connected to the internet, processed by Grab, leveraging big data techniques, because as I mentioned just now, they're processing terabytes of data per hour. And we use the old ways and the traditional relational database, it won't work, right? So you need to use big data techniques to do this. And just imagine, you know, just processing terabytes of data, you know, for Grab, which a startup just 5 years ago, where we haven't heard about this company, it was not affordable. But because they have this hyperscale cloud, which is really makes computing storage cheaper, they now can, you know, be such a successful company. And with all the data and computing that they have, they are automating everything. So if you think about it, you ask for a car at this point of time and then ask for a car an hour, a minute later, you find that the price may be different. And you don't think that there is an army of, you know, analysts in behind there trying to figure out what's the best price. It's all automated using artificial intelligence, right? So you see how this platform works together to the extent that the country manager of Grab says to me, he said, look, if you didn't have these digital technologies, his business model will just not work. A bit more about that later. So what is really happening today is that digital technology has done 2 things, as Google says, right? One, it gives the power to consumers. Think about yourself today before you want to buy your next handbag or your next car, or Reza, your next motorbike, maybe, yeah. You might have to, you probably know what you want to buy, 70% sure what you want to buy, right? So that when you go, you just want to browse other things, right? Which means that companies and businesses have to approach their customers in very different ways, right? But fortunately, the same set of technologies has enabled small companies to have big impact. Why? Because technology has been democratized and small companies have the advantage of being agile. And that's a key point. Companies today needs to be agile, right? and will have big impacts. And we've seen, you know, how again, Uber and Grab has been really disrupting, you know, decade-old transportation industries in a very short period of time. Yeah. And this is why Klaus Schwab, the CEO and the founder of the World Economic Forum, says that in this new world, it's not about the big fish eating the small fish. It's about the fast fish eating the slow fish. It's about and he says that, look, there's never a time where, you know, the technology has enabled huge potential. You don't have to be a big company, you know, your small company can be super successful. And you see that in that chart I shared previously. But he is also concerned that companies that exist today, if they're still doing business the old way and they're not changed, they're still tied to this linear form of thinking and business, then I think they'll be challenged to stay relevant and succeed in this new world. As an example, so just to say that, look, as a big company, existing company, you don't have to die. What you need to do is change, right? So this is an example of a company which was very successful between 2007 to 2010. And 2007 is when Apple I was launched, right? So they were very successful for 3 years. And then suddenly in 2010, they just died, right? In just about 3 months, okay? Or 5 months, yeah? And you know, if we had a face-to-face, I asked which company is this, and then most people say it's Nokia, right? It's not. It's actually BlackBerry. Think about BlackBerry, right? No one uses BlackBerry today. I know only about 2 people use BlackBerry in Malaysia today, right? I don't know why, but they're still using BlackBerry. But that company, what did they have to do? Think about it. So really, if you think about it, they had to create the next S-curves while they are successful. You cannot assume that if you have a successful business, you will not be disrupted and you can continue to do that business for the next 100 years. Unfortunately, that's not the way today. Every 3 years, you'll be disrupted, essentially, right? And that is why in today's world, company needs to have this dual personality. They need to run the matured business in a very efficient way, just like the way we do today, and leverage on the digital technologies to do that. But while that's necessary, it's not sufficient because of that disruptive impact. So they need to constantly innovate. They need to operate like a startup. So they have this dual personality, right? On one hand, structured, reduce costs, but they need to have a team which tries 10 stupid things and maybe 2 will be successful, for example, right? And this is not normal for traditional companies, right? So, and the culture of these 2 groups are very different. You know, the culture on the right side is, again, efficiency. Left side is taking risks and getting the market from 0 to 1 million as fast as you can. It might be even buying the market, for example, right? Now, just to show another example, I like to use Grab because they're a classic example. You know, started in Malaysia, but then they moved to Singapore, unfortunately. And remember that chart just now? Unfortunately, there's no Malaysian companies in there. Even Indonesia has got a few, by the way. All right. So if you think about Grab, you know, I had a fireside chat with the country manager about 18 months ago. And if you look at their interface in April 2019, they had only about 4 services, all right? And obviously, car was their right side of that cycle, which is their matured, you know, successful business, the car hailing business. And obviously, they're starting to play around with the food industry, with you know, logistics in the delivery, as well as fintech in prepaid. Yeah. Now, 3 months later, if you look at their interface, another 3 services came up, right? Again, that innovation side of things, right? You see, now you see hotels, which is totally different industry, right? That is what you know, travel, and then it's travel, trip planner, yeah. And in May 2020, again, you see additional thing. And if you look at your interface today, you just can count how number of services they have, right? A great example on how these digital companies today, they don't stop. And suddenly they are competing even post-Malaysia, they're competing against what else? Tune hotels, yeah. Many things they are actually competing against now. Fintech, which is essentially the payments, the payments industry, so on and so forth, right? And these are the interesting about how companies today have to be relevant, and succeed in this new world. And many of these successful digital companies, they adopt this two-sided, network effects on business, where the question is, how can I create more demand when I create more supply in a very, in a vicious cycle that becomes bigger and bigger and bigger, right? So if you think about, again, if you're interested in this, I would suggest you to read this book called Platform Revolution. Really, really good book. I really recommend this. You can see it. You can't. Okay, anyway, it's on the slide. Whereby they talk about, okay, if I have more drivers, it means I have more coverage. And I have more coverage, I have less driver downtimes. And because of competition, I lower the fare, I increase the pickups, and that would attract more demand, all right? And I have to look at this in real time because, I want to make sure that it's a good balance, because the danger is, if I have too many drivers, they might say, hey, it's not worth it for me to because the cost, the fares are too low. And then what happens is that when they have less drivers, there's less geo coverage, slower pickups, and so on. So it will actually reduce the demand, right? So it's kind of a very fine balance where you have to monitor these positive cycles and the negative cycles in real time. And this cannot be done manually, right? And that is why very central to all these businesses are data and artificial intelligence, right? But that's half of the story in terms of transforming the products in real time to engage the customers in real time. Because to enable this to happen, you also need to make sure that your organization, your people are empowered. Because if you look at this new world, it's about how people will, are actually working together to create this innovation or running the operations in the most efficient way. And secondly, is about the technology behind it. How do you optimize the operations of this very complex, very real-time kind of business, right? In terms of managing this double-sided network effect. So that is why in most organizations, when thinking about digital transformation, there are these 4 pillars about how you engage your customers, how you transform your products in real time, how you then enable the employees to contribute in the most efficient way. And all of this, you need to operate in the most efficient manner. And in today's world, they just leverage on data and AI to enable you to achieve this. So let's shift a bit to data itself, because this is very central. And I think this is a cliche now. Everyone has heard this. Data creates opportunities, the oil of the 21st century. Sometimes people say it's the goal of the 21st century. And yet, I bet when your hard disk is full, what do? You format your hard disk, right? And to Google, companies like Google, that's like throwing gold inside the drain, essentially, right? That is how they look at, why did Google buy Waze? Do you think it's going to make money? No, it's free service, right? It's because you think about Google, they know you more than you are based on your search and your networking and your emails and stuff like that today, right? But they don't know where you're going. But by buying Waze, now they know where you're going, right? So you can imagine, for them, having more data is going to give advantages for them, for example. This is one of those many companies. Now, why is data very valuable to these kind of companies? Because of the value they can extract from the data, and that's called analytics, right? We are familiar with descriptive analytics. That's, in layman's terms, is reports, static reports, okay? Everyone's got to produce these static reports. And I know that in some organizations, it takes a month to produce one static report, right? And then we talk about diagnostic analytics. This is where you have a bit more real-time access to data. You can have a dashboard. You can do drill down. So for example, in UPM, you might say that, okay, our number of our students increase, but the drill down you want to find out is, okay, which of these faculties actually increase, which decrease, so that you can address it in the right way, so that everything becomes better in the future, right? Now the next phase of analytics is actually predictive analytics. No longer is about looking behind, but looking ahead and seeing what will happen. Understand what will happen so that you can make the right decisions. Then the next stage is take action on what's happened. So the machine will itself take the required action. And finally, the advanced stuff is actually when we call cognitive analytics, where the actions are taken even when the circumstances change, right? So this is where essentially machine learning and deep learning becomes, and algorithms becomes important. But to enable this, you really require a body of knowledge, which today's world called data science, right? And that is why data science is becoming kind of an important area today. It's still an evolving area, by the way, and that's why, we don't have, and hopefully it's not, we don't have like undergrad degrees in data science because the body of knowledge is not quite well defined, right? Now let's look at data science itself, because this is underlying body of knowledge for machine learning, deep learning, and advanced analytics, and even AI, and I'll talk about AI later. In general, there is an understanding, it is a combination of actually computer science, which is straightforward, right? Information system, and mathematics and statistics, right? And that is why in today's, and if you look at this, like computer science and information are heavily towards computing. And if you did computer science, actually you need to be strong in math. You need to have maths, right? And that is why today in Malaysia and NQA, we decided that data science should be a specialization of computer science. Now this is arguable, right? So I'll address that, why that decision was made. But if I step back and look at it, right? And this is where I find actually mathematics is fundamental to all this, right? What is computer science? What it essentially is, actually to me, is applied maths, right? The principles of computer science, much of the core body of computer science actually applied mathematics, logic, and stuff like that, right? And that is why, coming in computer science, you really need to be strong in maths, right? And if you think about data science, so heavily probability and statistics, you need to understand that, right? And as computer scientists, you do learn about, probability and statistics quite heavily, right? So does engineering, for example, right? And really, if you look at most of this body of knowledge, the core of it is actually mathematics, right? Now, if you think about machine learning algorithms, like, this is where an IT person will struggle. IT is not computer science. Computer science, IT is different things, right? IT is about learning how to operate systems. They are expert users of systems. But if you're learning about computer science, you have to deal with this kind of mathematics. And that is why, in many ways, computer science is very heavily mathematics. And to me, as I said, it's applied mathematics, really, right? Without mathematics, really, you cannot do a lot of these things, right? And for you, probably this is easy, right? It's just base, right? And some sort of optimization of those models. But this is one of the many, machine learning algorithms that people use in the real world, essentially, right? But why is it not just pure mathematics? I think we need to understand that, right? Because if you look at the data science process, that part of the equation, right, is just this yellow bit. The whole data science process requires business understanding, data understanding. You need to be able to do some data preparation. There's a lot of programming here. There's a lot of understanding. So if you're using AI, for example, in vision, you had to actually deal with images, for example, right? And these are the kind of things you may not cover in traditional mathematics program, right? And then you need to then deploy the systems out there. So you need to have a bit of understanding on how systems work, how you actually install operating systems, so on and so forth. That is why, for the moment, that the closest kind of core body of knowledge will be computer science, but you need to have a strong mathematics in this computer science program to deal with data science, essentially. But I know many universities, like my son goes to, is attending University of Illinois in Urbana-Champaign. right? When we talk about data science, they tend to put it under statistics. But guess what? There's a lot of additional subjects they do, which is like computer science. In fact, they have a very strong computer science department there. And again, if you want to go in this area, this is where you need to, it's just not about mathematics itself, but you need to marry mathematics with computer science to be able to deal with this end-to-end data science itself, right? But as I said, at the end of the day, computer science, or they call it computational science, is actually just applied mathematics, just like statistics. Now, when we go to artificial intelligence, and this may be a topic which is you're not very familiar with, this is a science where you make computers do things that if humans were to do, requires intelligence, right? And what is intelligence? Intelligence is things like the ability for humans to adapt, and so if you see something else, they know what it is. For example, if you see a phone, it's a phone, but you see a rectangle, it's not a phone, right? So you can kind of adapt, right, accordingly, right? And adapting, if you look at the intelligence, there are many, it's a bag of words, which makes it very difficult. And the ones which are kind of normally, which is practical today, is things like understanding and interacting. These are the two main ones, and perhaps a bit of reasoning, right? These are the main ones which are currently maybe used in many AI systems today. But what we want to focus on in the real world is applied AI, because we don't want to have this argument about singularity, or it's about general AI where machines become like human beings. No. I think a lot of things are very narrow AI, and but then it is impactful enough to have significant implications, right? Now, I mentioned just now, AI is not new. It's 1950s. I mean, in the early days, they use what called rule-based system, knowledge-based system, where they have a lot of programming and if-else statements which implement all these human capabilities, right? But in the mid-80s, machine learning came up, where they use statistical-based algorithms, and rather than programming using code, they program using data. It's like teaching a kid, right? You give a lot of data, and then you make the kid answer the questions. Essentially be like that, right? And what deep learning does is that now you can have a lot more deeper neural networks, and a huge amount, and which requires a lot of computing, a lot of data, which means a lot of storage, that allows you to move the accuracy from the traditional like linear regression to neural network type algorithms that moves from maybe 70% accuracy in predictions to maybe 95% accuracy. And that has resulted in significant breakthroughs today. So without the hyperscale cloud economics for storage and processing, without the huge amounts of data, and that's why all these things interrelated, you couldn't have achieved the kind of deep learning performance that you see today. And the way AI is actually being measured is compared to humans. So for example, in object recognition, you give say 100,000 images. Humans then say what those images are. I think they had a 94.9% accuracy. And in 2016, and this list here is just Microsoft, and there are many other companies that have done other things, right? We beat that human threshold in 2016. That means machines at that point of time now became better than human beings in object recognition, okay? And 2017, we had speech recognition, where machines are doing better than human beings. 2018, three things: reading, translation, and speech synthesis, all right? And 2019, which is just last year, we had language understanding, right? So just a few examples, very quick examples. This is a speech recognition system where I mentioned just now, we achieved a 94.1% threshold in 2016. So listen to this carefully, yeah? And tell me what the person is saying. Okay, not very clear, so you're not ready, so let's try it again. So what did she say? No idea, right? Okay, I'll give you A, B, and C. And if you're face to face and I ask this, I would probably get maybe 60% people get it right. And the reason why they get it right is not because they understood what it says, probably the length of that sentence, right? And the answer here is C. So, it was hard for humans to figure that out, but yet, machines can actually quite accurately, understand what we were saying, right? So this is the advances that we have today. I'm running about time, so I'm not going to show you the other,
As the name suggests.
the other examples. I just want to maybe quickly move to this very quickly, right? Now, one of the things that you should realize is that in today's world, we shouldn't, well, I think we should deepen our fundamentals, whether it's mathematics or computing or statistics or whatever. But if you're deep in your fundamentals, don't use old tools, because the tools have changed quite significantly. In the old days, the reason why, again, AI was expensive is because you need, and data science was expensive because you need a big team. You need an IT person, you need a mathematician, you need a data engineer, you need someone with a business acumen, an application developer, and then someone who manages the database and so on and so forth. And it was very expensive, right? But in today's world, if you're bored in my talk, you can try this out. Go to this howold.net. Okay, it's an app. You can upload your data, and you can actually, it predicts the age of the person in the photos. Yeah, and of course, it's very accurate. Look at the photo of me and my daughter, right? The age that it predicts. Pretty good, huh? Pretty accurate. But the question is, how long did someone develop this? Okay. And I asked a seasoned, AI developer, data scientist. They say, well, maybe 5 people, 18 months. So it's about 100 man-months of work. Okay, but in reality, it was one person in Microsoft research, and I think it was a mathematician. I think just took 3 weeks. Okay, and in the 4th week, he managed to get 50 million users. And in this new world, 50 million users, like 50 million customers, 50 million hits, likes. And at the peak of it is 1.2 million users per hour, right? So we are talking about a very scalable implementation, just 3 weeks, right? This is the kind of speed in terms of people coming up with AI-based system. And this is actually quite a very useful application, because now I can use this system, and you can use it now, in fact, because it's just a web services that, you can take a photo of someone passing by and then predicting the age, and then have, for example, advertisements which are suited for this person. So if I pass by, I'll probably be, offered a walking stick, for example, right? But if, let's say, Dr. Riza passes by, he'll get a motorbike or something like that, right? So so it's a very, it's a real useful application, in my opinion, right? And the tools are quite simple. It's about, for example, in this case, it's about bottle counting for Pepsi. What they had to do, because in the past, what they do is they send people down to the stores to figure out how many bottles do they need, right? So what they did, hey, if I can develop an application which I just get the shopkeepers to take a photo of the area where the bottles are, and using AI, you can count the number of bottles which is required, or number of bottles which is left, right? That would be great. So a group of, I think, 2 people, what they had was they had a lot of photos of the stores, right, where the bottles were actually placed. And what they need to do is, for each of these bottles, they need to draw a box, and then they put a classification on, what it is, a Mountain Dew 1 liter, Mountain Dew 2 liter, or Pepsi Cola, whatever it is, right? So they just had to do that. And they had thousands of these photos. And once they labeled it properly, they just click a button, and suddenly they created an app which can be used on a mobile, right? So this whole thing, just in a matter of 2 people doing it for 3 weeks. And that's kind of how the innovation can happen today, right? The tools we have. So again, it doesn't mean that you have all this underlying knowledge. You have to use the old tools, because there are tools today that accelerate this. But obviously, if you don't have strong mathematics background, this is where your limit is. You can't do advanced things. And that is why I think, in today's world, as I mentioned just now, you don't have to have a big team to do things, and you can do things in a short period of time if you use the right tools, right? But as you can also see that you can just buy AI. I mean, obviously, like in this PowerPoint, it's pretty straightforward, right? You can buy a PowerPoint, which now you can see down there, it does real-time translation, right? And subtitling down there, which is not great, but reasonable, I think. Yeah. So for those of you who can't follow what I'm saying, or my English is bad anyway, right? But the thing is, you just can't buy this. It's kind of a journey for any organization, because the first thing you have to do is you have the data. Think about Pepsi tadi. If they didn't have all those photos available, they can do this in 15 weeks, 3 weeks. No, they can't, right? They needed all those photos. So data, having a data culture in an organization is important. And to afford to store terabytes of data, you can't use the old ways of your infrastructure. You can't use buying servers and maintaining every 3 years. You can upgrade with storage area networks and so on. You can't do that. It's just not feasible, right? It's hard to justify. But now with cloud computing, where the cost is so low that you can do that. A small company like Grab can do it, right? Now, once you have the data, this is where you can start to apply. And for example, in the case of Pepsi, they use what's called platform as a service to accelerate this kind of innovations that's happening very rapidly, right? And then with strong mathematics, with strong computer science, understanding statistics and so on, you can then do what the Chinas of the world is doing, the US of the world, and writing custom code and custom AI, which does even more fantastic things, right? So it is a journey. You can't just go to that AI without really having a data culture and also building up the right skills in an organization, right? But obviously you don't have to wait. You can start now, right? There are certain things out of the box you can leverage on AI, but I think you will not benefit that full breadth unless you have a strong data culture. And obviously also strong capabilities. And this is where our CEO talks about what we call tech intensity. It's not just about adopting these disruptive technologies, digital technologies, but it is also about ensuring that the people in the organization is able to leverage on these technologies, understand about how to deal with data, understand about how to do AI, for example, right? So it is important in this new world, especially now with that digital transformation happening, where companies need to transform this world, that upskilling, reskilling, relearning, whatever becomes very important. And that is why most governments today, including Malaysia, we're talking about everyone's trying to get people to learn. And this is a problem, I think, in my opinion, personal opinion, in Malaysia, because we don't have a culture of learning, right? Kita dah dapat degree, or dah dapat PhD, what happens? Hey, I'm the smartest guy on the planet lah. No need to learn, right? Engineers tengok cacing kerawik keluar, tak payah belajar dah, right? Unfortunately, it's a problem in this new world, right? And this is not the latest job disruption. I think a few days ago I saw this World Economic Forum jobs report. You can Google it again. There's a 2020 version, but it's very similar. Jobs today falls in 3 buckets. One, those which are going to become less relevant, or they call it redundant roles. I don't think it's going to be redundant. I think it's going to be morphed to something else, right? Stable roles, right? The roles which still will be required in this new world. But the good news, there's a lot of new roles. Okay, there's a lot of new roles, and we must make sure that if you're stuck in these redundant roles, you need to move to the new roles very quickly. And that is why reskilling is very important, right? And as I said, the good news is that for every job loss, there's going to be twice that amount which is going to be created. But maybe different things, right? And this issue was even happening 30, 40 years ago when PCs came in play, right? People say, oh, PCs will take over my job and so on and so forth. But really, it didn't quite happen. A lot of people relearned and did new things, right? In this new world, same thing, right? I mean, who would have thought there was a data scientist job today, which is the top job of the world today, right? Just maybe 10 years ago, right? So so we, and there's 2 reasons why. Because at the end of the day, humans still plays an important role in anything we do. This is called the O-ring effect by MIT, right? And the second reason what MIT says is that humans being humans, they always want more things, right? They want to achieve more, all right? Once they have AI, they suddenly innovate and say, wow, there's a lot of things I can do now, right? So it creates more jobs actually, right? One thing that you have to also be aware that even if you are in a safe job today, your job will not be the same. It will morph because the roles, the tasks in a job may change. So Accenture did this survey whereby they say that across all occupations that are relevant today, only 11% cannot be taken over by machines, theoretically, all right? Because it involves things like empathy, maybe, right? Creativity, innovation, and stuff like that. Which is a bit, machines are not quite there yet and probably won't be there for many years, okay? But 38% of the jobs will be totally replaced by machines. And which jobs are these? These are routine jobs. If you're doing the same task every day, these are the jobs which probably will disappear, the tasks which will disappear. But most of the jobs, 51% of the job is where humans and machines will work together, because it is when they work together that they will be more productive, right? If machines only, certain level of productivity, it's humans only, certain level of productivity, but when they're together, it just amplifies everything, all right? And that is why, you know, again, MIT talks about this thing called, you know, machine-human intelligence or collective intelligence, where machines and humans work together for even bigger impact, essentially. All right, and that is what is expected for all of us today. And it is for this reason, right? This professor from New York University talks about what AI does is put premium on skills that humans can do, right? Things which are non-routine, for example, where you have to think. That's why leadership and stuff like that, these are the things where it's a bit more harder for machines to do, right? And because of the need for us to constantly learn new things, this is where the World Economic Forum says that from 2018 to 2022, each one of us, including me, requires 101 days of learning. So if you've not started, you better start soon, okay? Since all of you are mathematicians, this is interesting, weapons of math destruction. And it's related to AI, why? Now think about this, right? If you had an analyst which evaluates loans for a person, or maybe insurance premium for a person, or, you know, the credit worthiness of a person, if this person is really bad, really bad at doing his job, at most he will impact, I don't know, 20 people a day, maybe 50 people a day, depends on how fast he processes it, right? But now, if you use artificial intelligence to do this, and you don't do a good job in your mathematical models, all right, and it processes 10,000 applicants a day, just imagine what will happen. The implication is big, right? And that is why it is important that as we design AI, as we develop all this automation, we need to make sure that we adopt good set of principles, right? And there are many out there, IEEE and so on, but for Microsoft, we look at this 6 set of principles. The first is fairness. You must make sure that the algorithm is fair. It doesn't look at your face, I don't like your face, I don't give you a credit, you know, a loan, for example. No, it's got to be fair, right? Secondly is reliability and safety, right? You think about an autonomous vehicle, you come to a very dangerous situation. The best way for the vehicle to perform is they take the safest thing, maybe stop by the side of the road, for example, not try to go on, yeah? Or maybe when they see a yellow light, what will happen? Kalau Dr. Rizal mesti jalan terus kan, right? But maybe the safe way to do it is actually to stop, right? The third is privacy and security, because again, if you do not ensure the privacy and security of data, then you are not fair to the owners of the data. And security is important because if it can be manipulated, the outcomes will be biased, for example, right, towards certain people. Yeah? Inclusiveness is to make sure that all the stakeholders are actually included in the system. So for example, you don't want to develop a system which will only work for maybe people with mobile phones. The solution should also work with people who are not connected, for example. How do you do that, right? So that everyone has access to these new kinds of technology. But across all this, I think transparency is important. This is where one of the areas of research today, is very actively in research, because just imagine if, in the case of a, self-driving autonomous vehicle and it gets into an accident, right? And, it made a decision that rather than hitting, the bike, it hits a bicycle. The first thing you have to figure out is, okay, who's at fault? Was it the bicycle's fault, the cyclist's fault, or was it the car's fault, right? And if you didn't have transparency in understanding why it made that decision, it's actually a problem. And unfortunately, in many of the algorithms, machine learning algorithms today using neural networks, it's not transparent, it's opaque. And that's why it's a kind of an active area of research to understand, why it made that specific decision. And finally, accountability, right? So when a car hits that cyclist and, you cannot say that, oh, I'm not accountable. The designer says I'm not accountable. It's actually the machine which made the mistake. No, you can't do that. At the end of the day, the designers, the implementers are accountable for this, right? So this is kind of the principle we take. There are many out there, but this is important because of that, again, AI is very powerful. It can be used for good and bad. And therefore, if you didn't have a principle-based approach, it can actually turn out not good for us. Yeah. So finally, I'll say that, whether we like it or not, AI-powered digital platforms is really going to move and accelerate the fourth industrial revolution further. It's not going to stop, whether you like it or not, right? So it is for us to be able to adapt and change accordingly. Yeah. I think mathematics discipline is actually very important, and that's why when I was involved in the recent Jawatan Kuasa Pendidikan Negara, yeah, we want to say that we have to make mathematics interesting for students, not hard, interesting for students so that they like mathematics. And I think all mathematics actually can be fun, right? But I think the way we present mathematics, especially in primary school, is kind of stressful. Right? And people die, and that's unfortunate because there's a lot of very exciting things. Yeah, I know. I'm going to stop soon. Don't worry. The third item is that if you look at, for example, that the whole phases of how you want to leverage on AI is a journey, right? It all starts with a change in mindset, change in culture. Because I would argue that if we did a survey that the problems that Malaysia has, we don't have two cultures. One, we have a data culture, and secondly, we are not embracing digital technology. We're paying a lot of money for technologies, but the old technologies. So orang dah beli kereta, kita beli kereta lembu, right? And we train people to run kereta lembu, which makes it worse. So with that, thank you very much. I'm sorry I ran a bit over time, but certainly I hope it was useful. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and have a good day and have a good weekend. If you have questions, I'll take questions.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Zahar, for the interesting overview of things, which comes from a helicopter view.
Yeah.
Where it sees the interconnectivity between the knowledge, the technology, and the way we perceive right now how the world is moving. Actually, it can be different tomorrow for all we know.
Yeah, it's going to be different tomorrow, by the way.
But the idea that the body of knowledge, which drives is a interconnectivity between traditional body of knowledges with technology, is something that has quite a difficult drive here in Malaysia, actually.
Yes.
Yeah, we can see in other places where actually these things are the norm, where education integrates and actually drives this type of upbringing for their students or for their younger generations. So maybe I would like to ask the first question then.
Okay, great. Surely the hardest, right?
No. It's so, is there any in your experience with the policyholders and so on, is there any direction in doing this properly in Malaysia?
Okay, it's a good question, and as I mentioned, I was involved in the Jawatan Kuasa Dasar Pendidikan, right? When it was about 1.5 years ago, we spent 6 months working on recommendations, especially in this area and how to deal with this thing called fourth industrial revolution. And I think a lot of people got it, in my opinion, right? Got it wrong. They think about robotics and do all these things, right? I think to me, if you look again at the digital technologies, as I said, the fundamentals there have not changed. Right? It's computing, right? It's computing, it's Internet of Things. What they? That's sensors and actuators. We learned that 30, 40 years ago. AI is 1950 and so on and so forth, right? But what has changed is how these technologies have been applied. Because it democratizes at different times, right? As I said, because now your mobile phone is so cheap, your smartphone is so cheap, that's why you buy smartphones, right? Okay, just imagine it was 10,000 each, we won't be using WhatsApp, right? Okay, so my take is this, that we should make all this quote unquote core body of knowledge, right? What I call fundamentals or basics, right? This core body of knowledge, we should deepen it and strengthen it, actually. It is counterintuitive because a lot of people are saying, oh, let's learn, mix up together, blah, 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 right? But really, if you think about it, a 3-year, 4-year course in mathematics, you're not campur lagi everything mati budak-budak tu. Betul tak? But I think all of us, all the degree holders should anchor on something. And this something should be one of the core body. If you're doing mathematics, then make mathematics as core. You're doing computer science, make computer science as core. If you're doing engineering, don't start to make new kinds of engineering like mechatronics. There's electrical engineering, there's mechanical, which existed for 100 years. Make it into a good core program. But if you look at all these core programs, there's always time for you to do electives. And that must be respected. Today, we tend to kind of make electives as a specialization. Now, I like to make it more loose, in my opinion, right? Because it depends on the students who want to say, I like maths, but I want to do computing, or I like maths and I want to do a bit more deeper into statistics, for example, right? But it is when they're given this choice of what they want to do, you can actually infuse applied. How do you apply this core body of knowledge? Develop the applied skills based on the core body of knowledge you have. So, for example, I could have a major in maths and a minor in computer science, for example, right? Can you imagine the kind of skills that you go out there, suddenly you have this combination of very strong mathematics and enough understanding of computer science to do good programming and stuff like that, okay? So the thing is this, the strategy should be that we should strengthen, especially at degree level, right? I'm not talking about TVET. TVET is a different strategy altogether. Deepen the fundamentals. Ensure that the applied skills that you develop is based on the latest tools, not on the old tools. Jangan ajar dia Fortran, right? Ajar dia Python, for example. Right? So I see what's happening in many universities is when they have a good core fundamental program, dia punya tools in the applied pun fundamental juga. Zaman lama punya, zaman saya punya, right? Pakai Fortran dan sebagainya kan. Or universities yang just belajar ajar tools je. All the latest is that fundamentally that strong, which means that it's hard for the students to learn how to learn, because when you have a strong fundamental, then you can anchor on that and you can learn yourself new things, right? And this is also part in terms of delivering of the program itself. You should really be very serious in getting the students to self-learn. And your role should be just encouraging them, guiding them, coaching them, right? Because they need these skills to really develop this interest to learn themselves. Because otherwise, you just spoon feed them. What happens when they leave? They don't have this self-ability to learn, which is so important in this new world. Yeah? And they don't have that skill coming from schools. Because schools today, again, some way before you get students coming and say, I love to go to school. Anak you semua suka tak pergi sekolah? Let me ask you. Anak siapa sendiri yang suka pergi sekolah? Tak ada. But if you look at other countries, right? Like in Australia, when my kids were learning in standard 1 and 2, bila cuti kan, dia boring kan, bila nak buka sekolah. That's how interesting school was, right? How can you do that? And that was the kind of things we were debating in the labs and how to do it. But again, you know, politics has changed things and everything. When a new group of people coming in, that slows down. But I've seen that there are initiatives happening inside Ministry of Education and Ministry of Higher Education and stuff like that. So let's just work together and figure out how to do it. That's my personal opinion.
And thanks a lot for the information that you're sharing. So I would like to open to the others. If there are any questions, you can also share your questions to the speaker.
Semua tak nak pergi cuti ke? Dah weekend dah ni. I don't see any questions.
Betul.
Budak tu ada question.
Saya nak tanya apa peranan social science dalam IT ni juga.
That's a very. I think social science is one of those sciences where it's going to become more important, right? Because you know, this is something where it will be very difficult for machines to take over, because you know, we don't even understand how our brain works actually, right? And hence it's very hard for us to emulate, you know, something like to understand social science. It's still a very long way. And I think as time goes on with the significant social changes itself, there must be a science behind it that we need to handle, because one of the biggest challenges that we see today is that socially that we will be changing also quite rapidly. And if we don't manage this properly and are unable to predict what will happen, I think there could be many things that will actually hold us behind, essentially, right? Because as I always say, the biggest challenge for us as a nation, as a society, to really be successful in this new world is that the biggest challenge is actually human beings themselves. Kita ada mindset yang susah nak tukar, because as I said just now, it is not about technology. Technology has been democratized, right? It is actually the people who say, why should I change? Okay? Why should I take this risk and change, right? Betul tak, Dr. Rizal? You know, UPM is a big university, right? You know, how many years you exist? Why should we change? Nanti kalau tukar kan, nanti my boss kata, you know, you ni apa kan? That's the problem. And this is where I think you are in social science. You should actually study this carefully. How do you break this? Allow organizations and people to take risks, for example. And that's one thing which, again, you know, just reflecting on Microsoft, we were doing badly, right? Until about 2014, until we had this leadership change. And one of the basic cultural move was that we went from a culture of know it all, everyone thinks they know everything, to a learn it all culture that allows you to take risk. Lepas tak boleh take risk tau. You take risk, you silap, memang matinya, right? To a culture which takes risk, because remember that S-curve, just taking risks, right? Try new things. We are not encouraged in new things. You're measured by trying to do new things. We're not afraid to try new things, but just don't make the same mistake twice lah kan? Okay? So this is a kind of, I think, social aspect, social science aspect that we need to handle. We're not quite there yet, right? People talk about growth mindset and so on and so forth, but I think these are the concepts which really will become very important to enable nations to be able to, you know, succeed and even, you know, be relevant in this new world, yeah? In all areas. I hope that answers your question.
Okay, thank
Gimana mathematics ada question social science, Dr. Rizal?
We do everything.
Oh, all right.
AI incarnate.
Nasib baik boleh goreng
Okay, so I would like to pass the session back to Dr. Haizat.
Thank you so much, everyone.
Right.
Have a good weekend.
Terima kasih.
Dr. Roy,
One
Okay.
question.
saya rasa dalam
Oh,
dalam
chat.
chat tu ada satu soalan.
Boleh tak you read it out?
Okay. So this question is from Raja Kamil, actually from Associate Professor Dr. Raja Kamil from Faculty of Engineering.
Okay.
Okay, so one of the challenges is the technology is moving faster than the syllabus could ever be updated, especially when the syllabus is updated only once every 5 years. So what can Dr. Zahar suggest to overcome this? Thank you.
Actually, I already answered it, but let me repeat because it's a very important question in my opinion, right? And now, yeah, I think what people are trying to do is, let us change the syllabus so that it is tuned to the latest tools or ways of doing things, right? But step back a bit, as I said just now, these digital technologies, the fundamentals of it has not changed over the last 50 years, some even 60 or 70 years, all right? So that is why I always propose, and again, the reason why I want to start this is because, of course, MQA punya pasal lah kan, dia tak kasih tukar cepat-cepat kan? Okay, I'll answer that too. Because I'm part of the Majlis Jabatan Kuasa Akreditasi kan, so kena lah defend MQA kan. But if you look at it, is that most of the fundamental knowledge has not changed. So what we need to do as program is not to try to create this multidisciplinary field to try to track technology. You should create on a field, or your program should be strengthening the fundamentals, because the fundamentals has not changed, right? AI has been around. So if you knew AI back in 1980s, it's very easy for you to learn about AI now, because tak ubah sangat actually. It's just that you have better tools to do it today. You have better computing to do it today. But the fundamentals are the same. And I argue, if you're from engineering and if you're either in electrical, mechanical, apa lagi ya? Chemical, and what's the other one? Civil, right? How can I forget civil kan? Do you think that the fundamental body of knowledge has changed? Even in computer science, the fundamental body has not changed. But what needs to be done, as I mentioned just now, is that in your programs, if you have assignments, if you have electives which are applied, make sure they are using the latest technologies, right? And let them learn themselves to use these latest technologies, right? So with strong fundamental, which is not changed, and the ability and interest to learn how to learn, you throw at them anything, they can learn, all right? And that is a strategy. So if you think about it, back to NQA, so that I boleh defend NQA, I think if you look at NQA, tapi you under board of engineers, so board of engineers saya tak boleh buat apa lah kan. But this NQA, board of engineers you kena lobby dia orang lah kan. But from NQA's perspective, I believe you can change 30% of the cost, right? Or 20%, I'm not sure, right? Without actually requiring NQA approval. Okay, so you think about it, I would argue that a majority of the courses, if you have a strong fundamental, that only takes you at least between 40 to 60% already, right? And the changes that you see is not going to happen that fast, like every year, but and if it happens, it's just changing the tools that you're using, right? And maybe some small techniques, and that is definitely less than 30%. So I always say okay, I'm not familiar with engineering sangat, even though I'm an engineer, but if I look at computer science, I always tell the universities is that separate your core, the subjects which are covering the core body of knowledge yang kena buat from the electives. Jangan campur. Kalau you campur, problem. That's why you cannot change the courses very quickly. But if you have a very clear core and you separate from the electives, you can quickly change the electives. All right. So and again, I don't know whether this applies to, I think it does, right? The problem kadang kita campur-campurkan, the electives yang very fast changing with the core. So if you can separate this, make sure that the core is core, and make sure your electives can actually change very quickly, I can bet you those changes are not more than what you don't have to go back to NQA to get approval, in my opinion. And that's how you make your programs agile at the end of the day. So that's just a thought. And also, it's more from an NQA perspective, but again, where the board of engineers allow this, I don't know. Yeah.
Okay.
Macam mana Dr. Rizal, boleh buat tak?
Boleh, insyaAllah, insyaAllah. Suddenly there is another question coming in.
Oh, another one. Alamak. You dah balik dah?
From a professor. Sometimes data analysis is presented as mathematics. I think the deep down, the mathematics is different than what we see. Well, I don't know what it means. Maybe you can repeat it.
No, I think it's a good question, because I think you've not experienced on how to do data science before, and I think this is where I would encourage you. Remember that 101 days of learning that you have to do? Why don't you take data science?
Yeah.
Right? You take data science, and then you'll see that, whoa, actually, if your mathematics background and statistics background, I think the parts that you will struggle a bit more is, kena buat programming sikit, for example, or have to manage data sikit, right? But really, for us, from an engineering or computer science perspective, the part where we struggle is actually the mathematics side. Because whilst we kind of understand how to do it, I think orang matematik ni, dia tengok matematik, dia nampak macam bintang kan? Macam have a feel. Betul tak, Dr. Rizal?
Yeah, sometimes.
But we don't have that tau. Engineers dengan computer scientists, we don't have that macam intuition tau.
Yeah.
And sometimes we struggle. Kita tengok equation ni apa benda ni kan, tadi ground semua kan. We don't have that intuition, and this is where I think those coming from a more statistics and mathematics background, they have this mental model and they have this intuition when they look at things. Oh, okay, this and the way they can deal with this is more, I would say, is it structured. While in the way computer scientists like me do it, I'll be doing trial and error, which means not as efficient. Yeah. So I would really encourage you to pick up. I really encourage you, if you really like to play with data, take a professional program in data science. I think you will enjoy it. I enjoyed it, by the way. Yeah, I did the professional in data science and AI. I think now my interest in computing is really escalated. I'm excited about it again. And I've lost this excitement for the last 30 years. 30 years. When I started off, I'm dealing with hardware, software, new kinds of programming approaches, object-oriented stuff like that. Then for many years, actually, it became quite boring because things became so easy. Yeah? Until now, last I think 3-4 years with AI, and next I would say quantum computing. They are all mathematics, by the way.
I think is the next thing. Yes.
Yeah, so you are in the right place. Cuma, don't just box yourself in the theoretical. That's important. Theoretical foundation is important, but very quickly apply this theory to the real world. Go into the applied world, whether it's computing, data science, whatever lah. It's how you apply mathematics in the real world. And maybe if you have a degree in mathematics, take either a professional course in certain areas of interest ataupun masters in certain area of interest, so that you have this mix, because your foundation is really good, as a mathematician, in my opinion.
Right. Terima kasih. There is another question, but I think this one you've answered. Which areas will be affected by AI? So I think maybe if you can share the slides, you can.
No, very quick one. I think it's important.
Right.
Just to understand. Basically, it's right like this, right? Don't look at the jobs. Look at the task, at the task level, right? If the job involves a lot of tasks which are routine, these are the ones which are highly probable going to be taken over by AI. So move to higher value tasks where every day is different for you.
Hmm.
And that makes you a bit more resistant to AI, because AI is not good at innovation, at empathy, for example, and so on and so forth. Right? So I hope that kind of gives you a feel on how, where you should be. Yeah? Kalau you buat the same job every day, memanglah, tunggu je lah.
Mengajar hari-hari, habislah.
Kenalah tukar ajar every day. Cara dia tukar, right? Yang besok cara lain, do flip classroom, guide people, coach people rather than teach them. Janganlah pakai lecture slide yang you dah buat the last 20 years. Itu memang nak kena tukar.
Okay.
Sorry I know all the tricks of lecturers, okay?
Alright, so I think Raizat.
Okay, sekali lagi terima kasih kepada Dr. Zahar atas perkongsian ini. Saya rasa 2 jam pun tak cukup kot, 3 jam banyak.
Cukup lah tu.
Okay, sekali lagi terima kasih kepada para
Terima kasih banyak ya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Kita jumpa lagi insya-Allah. Terima kasih semua.
Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh.